Alright, welcome back to the part 2 of this section. In the previous lesson, we are talking about a wire which has a magnetic effect when a current flows through. Subsequently, we bend this wire and it forms into a coil, a flat coil. Next, we bend this wire even more into multiple coils, which will form a solenoid. All of this itself, we can use our right hand grip rule, where our fingers will give us the magnetic field and the thumb will give us the current. Okay, so we can use it to identify how the magnetic field will actually direction of the magnetic field. So when we use this effect itself, what we can get is an electromagnet. An electromagnet itself can be used in many devices. So what is an electromagnet? Electromagnet are temporary magnets that form when a current flows through a coil. So we are actually making use of the magnetic effect of a wire. Okay, so one example that we can use in our daily life is a circuit breaker. We recall a circuit breaker is a safety device that is used to switch off the electrical supply when there is too much current flowing through. So we want to be able to cut off the current when too much current flows through. So let's see how it actually works. Okay, so in this circuit breaker itself, what happens is the current flows in from T1, flows through in here, flows through the solenoid, goes in and then comes out, flows through this, flows through here, flows through and out from T2. So this is the normal path when there is a normal current. What happens now is there is a surge of current, and then a few things may happen. So what will happen? Let's take a look here. So current comes in, flows here, flows into the solenoid. What will happen next is this solenoid will become magnetized. Okay, the solenoid will become an electromagnet, and this electromagnet will attract the soft iron bar. Okay, so this is the soft iron bar here. Okay, it will be attracted to the electromagnet. Why? Because now there's a surge of current. The current is strong enough. Remember, one of the ways to have a stronger magnetic field strength is to increase the current. So when the current is large here, this solenoid becomes strong enough. It has a larger magnetic field strength, it has a larger magnetic force, it will be able to attract the soft iron latch. What happened? The current will continue to flow, because remember this, the current will flow through and still has to flow out, and it will flow here and it will flow here. But now what happened? Because this iron latch has shifted down, okay, this bar here will be spring outwards because there is a spring. This is a spring. The spring will force this bar to move outwards and will break the circuit here. So as you can see down here is an open circuit already. So what happens? Current cannot flow through. In that case, because the current cannot flow through, the current will actually be cut off. Okay, so this is how a circuit breaker actually works. Next, an electric bell. An electric bell also makes use of an electromagnet in a similar way itself. So let's trace out, see how the current actually flows. So in this case here, the current flows from here, positive, through here, and into a coil. So as you can see here, when we use our right hand grip rule, this itself will give us that down here is a south pole, here is a north pole. Okay, using our right hand grip rule, this will form an electromagnet, because these are like two solenoids. The current will flow, current will flow, current will flow, current will flow. Now, since this is magnetized, by right, it's supposed to flow through here, flow through here, flow through here, and then goes back out. But because it gets magnetized, this whole bar will shift here. This contact area here will be broken. Okay? So this contact here will be broken. What will happen? They will lose contact and there will be no current here. There's no current here. So down here is broken. It's an open circuit. And what will happen is it will lose contact. Now when you lose contact itself, what will happen is there's no current. So let's come back to the loop here again. So when there's no current, down here we also have no current. So when there's no current, this magnet here, or probably an iron, will lose its magnetism. When it loses its magnetism, remember there's no current flowing. When it loses its magnetism, it will not attract anymore. And this bar will flip back out, and then there will be contact again. So now it's not broken. Now it will form into a closed circuit again. And when it's a closed circuit, what will happen is current will then flow again, and then it will repeat the cycle such that it rings, release, and then it keeps hammering such that it will be able to produce a continuous bell ringing sound. Okay, what other ways can we use electromagnets for? We can use it for MRI, magnetic resonance imaging, and we can also use it for magnetic levitation, which is used in trains. Okay, so with that, we will end the uses of electromagnets, which use on the magnetic effect of current in a wire. Okay, thank you.